Very good morning, students. We are going to start with our next lesson, which is waves. Yes. So, what is meant by a wave is it is a disturbance which carries energy as well as a momentum. Okay. So, wave is nothing but a disturbance. So, that is formed because of the disturbance, and it moves from one point in the space to another point without the transfer of medium. So, what is happening there is the medium is not being transferred. What is transferred here is only the object which is being placed, that is alone transferred. Okay, and that is a wave, and these are all the examples which are given. See here. So when you consider a rubber band like this, and when you make any changes to that, what happens? It vibrates. So when it vibrates, what happens? It makes a wave. And this is a still water. Okay, still water which is stable, and when you put any object inside that, what happens? It forms with the waves. And this is a wave which you have seen already in the sea, is it not? So these are the waves. Next is the formation of waves on stretched string. So consider that a string has been stretched with one end fixed. So this is one end, and that end is fixed. The other end is being holded by a person. Okay, and what he is doing is he's just going to shake this. Okay, so when he's shaking, what happens? It forms a wave. Okay, so this is a wave which has been formed in the string. Okay, we have the characteristics of wave motion. So what are the characteristics of wave motion is, first is for the propagation of wave, the medium must possess both inertia and elasticity. So whatever medium we are considering, that medium should have both what? Inertia. We know already about inertia, the inability to change its state, is it not? That is inertia. And also it should have the elasticity. So it should have some elastic property. If it is not elastic property, then the body will not have any wave. Okay, which decides the velocity in that medium. Second characteristics is, in a given medium, the velocity is constant, whereas the constant particles in the medium move with different velocities at different positions. So it is said that the velocity is constant, but whereas in the constant particles, so what are all the particles which are in that? It moves in the different velocities. Okay, then the velocity is at the maximum. Velocity is maximum at the mean position, and it is zero at the extreme position. Okay, so as we know, when you consider any wave, so these are all the mean position. So what is meant by a mean position is that is at zero position. Okay, and these are all the extreme position. So extreme position can be either positive in this way, or it can also be negative. Okay, so these are all the extreme position. So when you are at the mean position is zero position, we can say that the velocity is maximum. Then at the extreme position, we can say that the velocity is minimum, or it is almost equal to zero. Okay, then the waves undergo. So what are the property that waves undergo is, it undergoes with a reflection, refraction, interference, diffraction, and polarization. Okay, so what are the properties that waves undergo? Reflection, refraction, interference, diffraction, and polarization. Clear? Next we have the mechanical wave and its types. So wave motion can be classified into two types. What are the two types of wave motion is? Mechanical wave and non-mechanical wave. So what is a mechanical wave is the waves which require a medium for propagation. So which has any medium, and through that medium if any wave is propagating, that is called as a mechanical wave. Example we can say is sound waves and the ripples formed on the surface of water. And just now we saw when the water is stable and we make any disturbance, that forms a ripple. Next is non-mechanical wave. This does not require any medium for propagation. So ஏதாவது ஒரு மீடியம் இருந்தால் தான் போகும் அப்படின்றதுலாம் இல்லை. Okay, example we can say is light. Okay, then also the waves are further classified into two more types. What are they is? Transverse waves and longitudinal waves. Okay, so what are the two main types is? Mechanical and non-mechanical. Then further they are classified into transverse and longitudinal waves. Now let us see with what are the transverse as well as the longitudinal waves. First one is transverse waves. In the transverse wave motion, the constituents of the medium oscillate or vibrate about their mean position, and it vibrates in a position which is perpendicular to the direction of propagation of the wave. So if you consider any direction of propagation of the wave to be in this position, then that particles will vibrate in the perpendicular direction in this way. Okay, so in transverse wave motion, the constituents of the medium oscillate or vibrate about their mean position in a direction which is perpendicular to the direction of propagation of the wave. Suppose if this is a direction of propagation of the wave, then the wave will vibrate in the perpendicular position. Example, we can have it light, which are the electromagnetic waves. Okay, and you consider the example that any wire or string which has been attached like this, and if we make a movement, what happens? It moves, and that is a transverse wave. Next one is a longitudinal wave. So opposite to this, if this is a propagation of the wave, then the longitudinal wave travels in the parallel direction. Okay, so in longitudinal wave motion, the constituents of the medium oscillate or vibrate about their mean position in a direction which is parallel. Here direction is perpendicular. Here we can say the example is sound waves which is traveling. So in longitudinal wave motion, the example is sound waves which is traveling in air. Here it can be either compressed or stretched. Okay, so let us see with the comparison of transverse as well as a longitudinal wave. The first point is the direction of vibration of the particles vibrate perpendicular direction, here in the parallel direction. Then the disturbance is in the form of crest or trough. So what is meant by a crest or trough is, so this is a wave which has been formed in the longitudinal wave, transverse wave motion, is it not? So this maximum position, that is called as a crest, and the minimum position, that is called as a trough. Okay, so in transverse wave motion, it forms with what? Crest and trough. And here it forms with a compression and rarefaction. So as we have seen already, here it forms with a compression and rarefaction. Then transverse waves are possible in the elastic medium, and this is possible in all types of media. Okay, so transverse waves are possible in elastic medium, and this is possible in all types of media. Yes, clear with this? So this is a comparison of transverse as well as a longitudinal waves. Okay, next we have the few terms which are involved in the wave motion. Okay, so the highest point in the shaded portion, that is called as a crest. As we know already, when we have the wave in this form, the highest position, that is called as a crest, lowest position is trough. Same way, highest position is crest, okay, lowest is trough. And between any two, one crest and one trough, if you combine, that is called as a wavelength. Okay, so one wavelength is lambda. Then crest, trough, same way crest and trough. So combining together, we have the two wavelengths. So it is 2 lambda. Okay, and what is the frequency is? It is the number of waves produced in 1 second. So consider the time as 1 second. For that, if you count the number of waves, okay, so how many number of waves is there? So one crest and one trough. So one, then this is 2, and this is 3. Okay, so 3 plus one crest trough, if you consider, it is 4. So number of waves is 4. So that denotes your frequency. Okay, so we can say that the time period is always inversely proportional to the frequency. So we can write T is equal to 1 divided by F. So time period is the time taken by the wave to cross a point. Okay, so if you consider one point, to cross that point, how much time is being taken? If you just calculate that, that is a time period. Okay, and the dimension of wavelength is given by lambda, that is equal to L. Then the frequency is given by 1 by time period. Okay, so we can write F is equal to 1 by time period, so 1 by T. T, if you are taking to the numerator, that becomes this T inverse. Okay, now if you need the value of lambda into F, okay, so lambda into F, which is equal to, we can write separately as lambda, and F, what is lambda is L, then F is what? T power minus 1. So we are writing it as L T power minus 1. That is nothing but equal to the velocity, because the velocity, the dimensional formula is L T power minus 1. So velocity can be written as V. So lambda into F is equal to V. So this is a relation between frequency, wavelength and velocity. Here V is the wave velocity or the phase velocity, and the wave velocity is the distance traveled by the wave in 1 second. Yes, clear with this? So this is a relation between the frequency, wavelength and the velocity.